Is?
All right.
G'day, yo.
Hello, yo. You're on mute there, yo.
Yes, yeah. Good morning. Good
Hey,
morning.
hey,
Morning.
hello,
Good
hello.
Good
morning. Good morning
morning,
to you.
Greg, Rafe, and
How are you?
can I call you Hadi?
Yes, this is exactly true.
Okay. I just jumped
Fantastic.
from the other session, the keynote session, which was a very good session as we're used to Rudiger, Greta. So thank you so much for
Excellent.
waiting.
Perfect. All right. Well, there are people that are
Ah,
still filing in, but I think we'll
streaming
uh,
it.
we'll we'll start off now and at least start with some introductions before we dive into some questions. So first off, welcome, everybody. I'm Greg Lemichon with Fluitec, and I will be moderating a fairly esteemed group of experts here today. So I'm honored to be moderating this session. So we have a global team here, and I'll ask each person to introduce themselves. But we have Rafe, Hadi, and Yo. So Rafe, why don't you start off and give a quick introduction and maybe mention where you're located in the world right now as well.
Yeah, sounds good. G'day, everyone. I'm Rafe. So I'm usually based out of Sydney, Australia, and currently in Perth. So that's nice. It puts me 3 hours closer to the Europe time zone. I'm the lubrication explain guy from YouTube. That's probably how most people know me. And I've got the podcast, Lubrication Experts. So for the most part, right, I don't know anything. I just get to interview people who do know a lot more than me. No, but and I work as an independent consultant, kind of serving both sides of the industry. So I work a little bit with oil companies, and I work a little bit with end users as well. So kind of get to see all the way up and down the stack.
Wonderful. Thank you. Hadi?
Okay, thank you, Greg. My name is Hadi Qahtani. I am currently located in Saudi Arabia, Middle East, working for Saudi Oil Company. We are a user of different type of oils and machinery. We have thousands of machines in our company. We also deal with the manufacturers, and we have our own standards, and we have our own laboratory for oil analysis. I joined Saudi Aramco 28 years back, mainly, with the rotating coolant division. I'm the chairman of the company Lubrication and Vibration Standards. And that's it, Greg. Thank you very much.
Wonderful. All right. Welcome. And Yo.
Yes, Greg. Well, I and everybody on the call, thank you so much. My name is Yo. I'm a colleague of Greg at Fluitec. And today I'm heading the sales team of Europe. I've been involved in the very first days with the ruler technology, which is a name that is going to come a few times through this session. And today, as besides sales, I'm also very much involved with the key accounts, OEMs, companies, and like Rudiger is saying, networking and trying to help people with our expertise at Fluitec. So I look forward to this session today.
Fantastic. All right. Well, thank you, everyone. So the topic is how we go about developing condition monitoring system for critical turbines. So before I ask the first question, I think I should try to clarify maybe a little bit what a critical turbine is. So if you look in the world of turbines, I would say hydro turbines, not so critical. It's a fairly easy application for oils, and you can have turbine oil lasting literally for decades in a hydroelectric turbine. As you kind of transition to steam turbines, we would have kind of older generation steam turbines, and some of the newer generation steam turbines actually are much more stressful. And then in the going down into the world of more stressful critical applications, we have gas turbines. I would say the frame units, the much larger gas turbines, are probably less severe on the oil than the smaller industrial gas turbines, where you may have all of the controls are integrated. They're burning much, or they're much hotter, and a lot more thermal stress in the oil. And if we stretch this maybe just a little bit beyond turbines, if we look at compressors as well, compressors can be very, very harsh on the oil. So in terms of critical, I think I think some of the modern steam turbines, the gas turbines, and even growing into the compressor world is kind of how I would think of these turbines in terms of criticality and severity on the oil. So let me start off here with the first question. What do you do to set up a world-class oil analysis program for turbines? So we should have a couple different perspectives on this. We have Hadi is an actual end user who is setting up world-class oil analysis programs for, as he said, thousands of assets. And Rafe and Yo also are advising end users on how to do this. So on the first question here, Rafe, why don't you kick us off with your view on this?
Yeah, that's a good question. And like so many of the questions in that I've experienced at LRVS, the answer is always it depends, which I know is a really unsatisfactory answer. But when I help my customers with this question, I'm probably considering a range of different factors. So one would be where is the asset in its life cycle, right? So are we setting it up at the very beginning because it's a new installation? How old is the turbine? One would be, we've already mentioned that it's critical, right? So that we kind of tick that box already. What kind of oil system is it, and what's the expectations on failure mode? So we spoke to the idea of the frame gas turbines, right? So your standard sort of mineral oil formulation. I do a lot of work in the aeroderivative space. So polyol esters, completely different. We're expecting coke formation rather than something like varnish. And then you've got the environment as well. So speaking about those aeroderivatives, a lot of the failures that I see, at least up in the tropics in Australia. So all our LNG facilities are up the top end. It's water ingress from the atmosphere. So even if the turbine's not operating, which in a lot of cases these things are operating in a peak capacity, even if it's not operating, that oil system is just sitting there, just absorbing water, right? And the TAN is just steadily increasing, even though the unit's not actually operating. So you put all those factors together, and then you can start to make some decisions.
Fantastic. All right. Hadi, why don't you kick us off with your view on this? And you're on mute as well.
Okay, thank you, Greg. This is a very important question. Really, to set up, a program for critical turbines to require some efforts, and some investment as well. Company need to have their in-house, laboratory or third party that they can do sample analysis of the turbine oil. The in-house lab should be equipped with basic, tests like MBC, ruler, and other, basic, tests. Also, we need to have a training program for your people, because it is not sufficient to have lab equipment and devices without proper training and education of the people on the plants. So training plays a very important role here, and we have noticed lubrication probably is not given the right attention by some companies, which is they focus on other programs, but you need to have the proper people and train them how to use these devices, how to conduct, how to manage the lubrication and monitoring program of critical turbines and other assets. This is, in my view, Greg, and it's your turn now.
Perfect. Excellent. All right. Thank you. Yo, what do you suggest to customers who wish to set up a world-class oil analysis program?
Well, I think we heard already two very valuable opinions. I believe, my opinion, it starts with the competences of the people. Is that you need to set up a team of competent people. That means that if you want to have people from operations, maintenance, logistics, they should be all involved, because it should not be just an island who in plant for maintenance who's making all the decisions, because then it's becoming very difficult. And then the education of the team is very important. Explain them how to sample, sampling procedures. The quality of your oil analysis program starts at large with the sampling oil quality. I see too many times that people still take a sample from a system who is down or in downtime, and you cannot take a representative oil sample. Understand condition monitoring standards and practices. I will have a session later to talk about that. And like Hadi said, and Rafe, is put time in selecting the right outsourced oil analysis laboratory. Focus on the quality of the lab rather than on the cost or price. Free oil analysis today just make it's not the right oil analysis. You need to have a speed of reporting, digital platform of oil analysis data that you can quickly access. And then the more data you have, I like the word trend is your friend. That means the more data you have, the more sampling frequency you have. And that's why Hadi is also saying having an oil analysis on site, a mini lab with like particle counting, MPC ruler. It's so valuable. And the last point I can add to that is look at incoming oil quality control. How do you store lubricants? I mean, and then it's put in a poor quality into the system. That is also condition monitoring for your critical equipment.
Very good point. Yeah. Also, the oil formulation may change, and if you're not running incoming analysis on the incoming samples, then your baseline may be changing. So, excellent. Well, I want to encourage everybody that's listening to feel free to answer some questions. And we have several other questions here that we want to get through. But I think the most important thing is if there are any questions from the attendees that I want to try to get to those. So there's one question from Rao that has asked about condition monitoring of if I understand this correctly, a steam turbine-driven compressor train where you have an integrated oil reservoir, and there's a risk of water ingression. So how would you go about setting up, or what things would you think about in terms of setting up an analysis for an asset like that? And I'll open it up. Anyone that has some thoughts on that.
Well, sorry. Water. In any case, water analysis is contamination is a major parameter for any oil analysis program. So if you have ingress of water, today I've seen that you should be very critical, because in my young days, 200 ppm was a common practice. Nobody was taking care of it, but today systems are much smaller, and water ingression with I would say factors of 50 ppm for me is already an alarming level. So I would really consider if you know your system is sensitive to water buildup, then you need to increase the oil analysis frequency and make sure you pick up the right moment where water is increasing, and then you put a vacuum dehydration on it, and you make sure there's no oxidation occurring because of the water, and then I don't think there's really a large issue, my opinion.
So crackle test?
Yes, but now we go back. Yes, you can in a mini lab. Yeah, you could use, but there's today small car fishers that can be used in mini labs, and they're really performing. I must say, it's amazing how good this equipment works.
Yeah, Hadi, Rafe, anything to add to that?
In addition, yes, Greg. In addition to what my colleague said, You need to increase your sampling frequency. Also, you need to look to the root cause. What caused the water ingression? You need to look to your machine and fix the root cause. But this is a challenge. I agree with the question. In the steam turbine applications, it is a challenge. But with proper care and with proper monitoring, assessment, root cause analysis, you will be able to find out and to improve and to prevent that from happening.
Yeah. Very good point. Excellent. Anything to add to that, Rafe?
No, I think the other two have covered it pretty well.
Okay, excellent. Well, so actually, I do want to ask a question on sample periodicity and how often you should actually be taking the sample, and what influences this? Is it the formulation, the criticality of the turbine? So how would you go about setting up oil analysis testing frequency? What are your thoughts, Rafe?
Yeah, I mean, so for me, the first thing I sort of do is make a decision on which time parameter you are going to be doing your interval. So, is it, for example, operating hours, or is it just calendar hours? And for me, at least, that was often dependent on, whether the failure mode is a function of operating time or, environmental time. So going back to the aeroderivatives as an example, some of my customers, I actually put on two different oil analysis intervals, right? So one of them is looking at environmental ingress of water, which just happens, right? Especially if they've got no nitrogen purging systems, the water just comes in, the tan increases. Now, in those instances, like Yo was saying about sampling, you're not sampling when the engine's running, so to speak, right? So the samples that you're taking there are not representative of what the oil system will look like while it's operating. So in some cases, I've got them taking samples at regular intervals on a calendar time when everything is off, purely to measure how much water we're bringing into the system and how is that affecting the acid number. And then separately, we're doing samples while it's operating, right? And doing those on an operating hours cycle so that you can watch the other kind of degradation of the lubricant in sort of in service. So that would be an example where you're doing two different tracks of oil analysis. For your mineral turbine oils, usually I'd do those on operating hours, because if you're expecting sort of oxidation buildup and varnish, you expect that to be a function of how long has the oil been at a high temperature.
Great. That's super interesting, having two different analysis programs for one asset, depending if it's offline or online. That's really interesting. All right, Hadi, do you have anything to add to that in terms of sample periodicity and what will kind of change sample frequency?
Actually, Greg, it depends, on the application, on the criticality of the machine, and on the issues that you are facing in the plant. You need to adjust, your normally it is monthly. This is the rule of thumb. However, it is not the case for every asset, for every condition. You need to go back and adjust as needed. It's like your BM. Sometimes some BM is good for 3 months, but however, you need to do mini RCM to adjust your BM frequency. This is exactly the same. Your sampling should be visited from time to time, based on the history, based on the issues that you are facing. This is my opinion, and this is the practice that we are using here in the company.
Fantastic. All right, excellent. We have one question here from the audience from our friend from Qatar. Vanda has a question on acceptable and maximum limits for each oil analysis parameter. And what do you do when the OEM has one suggestion, and then maybe the lubricant manufacturer, in other cases, it could even be industry guidelines like ASTM or ISO, have conflicting and the recommendations are not always matching. which one should you follow?
I think if I can answer that question, I believe that as an really active member of standardization organizations, we put a lot of efforts in keeping those standards up to date, especially ASTM, DIN VGB. That means that we have in those group people from the field, we have oil companies, we have OEMs, and we try to keep them up to date. For example, I will speak about that later in my session, the MPC values. We have been looking at them to update them to realistic values before taking an action. But secondly, I don't think we need to take this an absolute viewpoint, trend your data. If you perform enough oil analysis data, either in combination with your outsourced lab, in combination with your mini lab, where you screen oils, you perform more data, you follow a trend. And it's not just so important to say if my foaming is now 350 or 450 milliliter. Now it's to see that I see a sudden jump from, let me say, 50 minutes to 500, or an air release is suddenly increasing from 4 minutes to 8 minutes. I think that is more, if I can recommend Vanda to look at trends. And again, once again, all analysis labs, they're very strong in building up recommendations. They know very well the combination, the matrix of data, and coming up with recommendations on oil analysis frequencies and also actions. So that is my viewpoint, how I look at that.
Very good. Rafe, Hadi, anything to add on that?
Yeah, I mean, often it's commercial, right? And sort of like the decision gets taken out of your hands. If there's obviously any warranty concerns, and I'm, mostly speaking beyond turbines there. The other way that I kind of look at it as well is the measured quantity that's coming out of the lab, is it affected more by the machinery, or is it affected more by the oil? And you kind of go to each kind of unit specialization too, right? So, when you're looking at oil degradation, it's likely that the oil companies probably have defined limits that might even be based on their formulation, and that's information that only they have. When you come to things like wear metals, PQ index, which is more indicative of the let's say the condition of the equipment, I'd probably lean on the OEM side. So that's maybe another lens to look at it.
Really good point. Yes.
Yeah. Well, it's also like Rudiger was saying in his session. I would never rely on one source. I think it's like you have a team and you have people who are able to look at ASTM or an OEM specification, or have a good relationship with the oil company, and then bring it together. And I think it's never a black and white situation.
Yeah, definitely.
That is so
what
true.
it is.
I agree with you. In fact, we rarely, face, big discrepancy or difference between the ASTM and the OEM. It's rarely, but if it has happened, it will require attention. ASTM actually gain, confidence in the industry and to be a reliable source and limits of the low oil, analysis and limits. However, OEM could have different, figures that would require case-by-case evaluation, but generally we go by ASTM.
Yeah, that's really good. I like the concept that you should take as many inputs that you can from as many sources. Ultimately, ASTM does not own your assets. The oil manufacturer does not own your assets. The OEM does not own your assets. So you need to take into account as much information as you can to take care of your asset.
Exactly.
Yeah, really good point.
And the future is going to be also online. Let's not forget, I saw a question from Bruno or Kaiksa asking, what do we do with online data? What are the limits there? I think, well, first of all, today, there's still a lot of to be done in online technologies. There's a new emerging technologies coming up, but I think it's going to be very important, online sensors in combination again with oil analysis labs, and find then again the matrix, how it can be used at its maximum value. Huh?
Yeah, it's a great, that's a great question about what parameters should you take into account if you're selecting online monitoring. So, for example, there's a viscosity sensor. Does your turbine oil fail because of viscosity? How important is that sensor? So, Rafe, what do you think?
Yeah, that's a good one. And I think you definitely, well, I mean, that's basically would have been my line of thinking when you were sort of mentioning, does your oil tend to fail on viscosity? I haven't seen too many turbine oils fail that way, unless there's like egregious cross-contamination with another lubricant, which, has been known to happen. So you're right, you're kind of speaking to what are the likely failure modes and what is the things that I need to track on a more frequent basis than I could get out of standard oil analysis. And so, you can definitely get more of a trend. So, we've seen some online monitors that are able to kind of do an approximation of ruler or kind of like the oxidation. If you are seeing varnish, that might be something to strap on to, one or two of your assets to see if you can get a more high resolution trend. Same with some of the particle count sensors too, right? So, there's potentially something there. To be honest, I'm kind of talking out of school here because I don't know that much about the online monitoring world.
All right, well, Hadi, let me ask you, and I want to expand this just a little bit for your from your perspective, Hadi, since you have so many different assets that you are managing, and do you see online sensors as a future direction for you, or in the world of turbines, do you see in the next decade or two continuing to send oil analysis to your in-house laboratory?
A great question, Greg, and I have seen the question by Borno. Actually, this is part of my presentation after around 15 minutes. Definitely, yes. The online monitoring is the technology is getting improved. The algorithm developments, we see a lot of improvements, and we have good examples, and good experience with similar, the vibration monitoring system. We have online sensor that will protect machine from tripping due to high vibration. And I think the future is also for oil sensor that will be equipped online. And it's part of my presentation. Not necessarily to trip, as Rafe say, but we might have it for alert, to alert our reliability and operation people about something going wrong. I cannot wait for oil sampling to be taken after 1 month, then sent to the lab, do the analysis. I could have something in between that cause, a trip or a problem in my machine that will cause a shutdown, which will impact the production. So the oil sensor, online sensor, to me is a future. And we actually, we started, some work with companies in Canada and in Spain to really develop these sensors. We sent some oil from the company to them to develop their algorithms, and it is finished. It has been developed and ready for use. We are going to install it in one of our machines, and we will grow. And I'm sure one day the online sensor for lube oil will become similar or close to the vibration online sensor that has been there for more than 40 years. And no machine now can be installed without the vibration. I'm sure one day we will have online sensor as important as the vibration sensor. So this is in my view, and I from this, great, gathering, and from this great summit, I really would like to invite all experts to really give this, further, consideration in terms of development, in terms of deployment, and in terms of standardization. That will make it happen in the future.
Yeah.
Well, that is a inspirational way to end this session. I feel bad that we have literally just you guys are amazing. We have so much knowledge here in this, and this could be an all-day roundtable discussion. But unfortunately, we only have 30 minutes, and our time is up.
Greg, just if you allow me, Greg, just to answer,
Yes.
Bruno's question. He was asking what are the main parameters that we should consider, for online. There are many, like we need to look into the antioxidant, particle count, water content, and sensor can do that for us. The viscosity, as you have highlighted, and my colleagues also, the acidic number, and so on. So this is just to address the question. We went deep to the online, and we forgot to answer the main question.
Good point. Yes.
Thank
all
you.
right. Very good. Excellent. Well, thank you all very much for contributing. And I think this is a great session, and it was an honor for me to moderate. So thank you so much. And I hope everyone enjoys the rest of the conference.
Thank you so much.
Right.
Bye,
Thanks,
Hadi.
everyone.
Good luck. Good luck with your presentation, guys. Later.
Thank you so
Good
much.
luck, Hadi.
And thank you for our audience, to be with us, today. Thank you very much.
Yes, thank you so much.
Right.
Thanks for listening,
Bye.
everyone.